I'd like to welcome you on the next presentation on the cloud and deployment and MLOps track. This time we're going to have a presentation around working with production models, deploying them with Kedro, basically. I'd like to introduce Mariusz Strzelecki from Getindata, who has been working with Kedro and the whole stack around on one of the projects. Mariusz, the stage is yours.
Thank you. As Chairman already said, I'm Mariusz Strzelecki. I work in Getindata as an ML engineer, and I'm going to show you a short presentation how we made a model serving really easy using Kedro pipelines in one of our projects. So first, what do I mean by model serving? By model serving, I mean deploying a service, microservice, that others, like other users or other processes, can ask for a prediction. And as you may know, we have plenty solutions that provide this functionality. We have Mlflow that can serve the models like sklearn or some XGBoost models. We have Seldon that provides also a lot of components, containers for serving different models. And probably there is a lot of other tools in this space, but I was working with these two above, and I can tell you a bit about them later. There's always a way to serve a model by just creating a microservice, right? Because the model is just the pickled something that you just unpickle and you can just call. So you can always create a microservice that will do everything that is needed to serve a prediction. Before we go to the main topic, let's serve a model. So I actually took one of the examples from Seldon, and this will be Iris, of course. Let me first run it. Iris YAML, and while this is starting, I will show you how the model deployment in Seldon looks like. So you create object of type Seldon deployment, and you deploy this object on Kubernetes. And here you have a name of the container that is supposed to serve this model. And in this case, this will be sklearn Iris, something that you can find in the quick start. Let's see if if it already started. Yes, it's free, it's running. Let's try to ask this model for some prediction. Oh, not this one. Iris input. So, as you may know, Iris recognizes what type of flower is this, what type of iris is this, based on 4 numbers. So I will just use this 4 numbers. I will go into the model server. I will refresh it. Oh, I need to authenticate. Just give me a second. OK, and if you deploy a model with Seldon, it provides you this nice Swagger interface. So you can just enter the predictions API. You can just click try it out, and you can just put any input for the model. And when you hit execute, the request is made to the underlying server, and you have your response. The response is here below, and it says that basically, most probably for this dimensions, this is Iris setosa. And yeah, that's basically all. Let's go back to the presentation. It was easy, right? Basically, I just typed one command. I had some YAML prepared, but I actually copied it from the tutorial only. So I just deployed model with one command, and I have this on production as a REST microservice. So why do we need actually this presentation? Is that it is because Iris model is usually nothing like the models that you create in your projects, for the models that provide the business logic that your company or your project needs. Because, for example, real models, I do not mean that Iris is not the real model, but the real models, the models created by you, they usually have way more parameters. I was working with a model that consumed like 500 parameters on the input. And imagine asking some developer, web developer, oh, if you want to get a prediction, just pass me this 500 numbers and I will get you an accurate prediction. It would be very challenging, I would say. Real models, so models that you create, they usually require some transformations. But transformations, I mean, for example, value scaling, like in the data you have values from 1 to 10, but model expects from 0 to 1 because this is how the model is created, or encoding. Real models should validate input. If I would go back to this iris example, and if I would put a negative number, it would still give me some kind of prediction, but I do not know if this would be valid or not. But real models should validate input and tell you, okay, I cannot answer you this question, I cannot give you this, this prediction. Real models may depend on data from feature store, so from some central place that you may have in your company that serves the data on your domain, like your clients, all the users, and so on. And real models are trained on the data from feature store, and they may require to connect to feature store while serving. And this is not something that Seldon example can show us. Finally, real models may require some post-processing, like the iris it provided as free float numbers, and we would like maybe to just get a name of a species of iris. So this is already supported in the both frameworks that I showed you on the first slide, on the second slide, because in Mlflow you can create the small Python class with 2 functions only, load context and predict, and you can store this function in Mlflow near the model. Mlflow is just a model registry and model tracker. So you can store this function there, so you can create any code that you would need to be executed before or after calling a model. So this is actually a pretty nice solution. Seldon also provides something similar, but they call it Python components. You also create a class with 2 functions only, one for initialization, second for prediction, and you just deploy this class into Docker container and you deploy it to the registry, and Seldon starts it and you have your code running in production. Also, if you have some transformations that can be reused across different models, for example, something that is common for your organization, you can use this complex Seldon core inference graph with this green box in the middle that allows to extract the feature transformation as a service and deploy it as a second or third separate microservice that would be called when the model is called. So then you can actually reuse transformations across different models. So yeah, it looks like, well, this is all awesome. All these products, they support delivering some customization to models that you trained. But there are some issues that we faced on the projects that we were working in. So first issue is that you keep every model in 2 sub-projects. You have a separate training sub-project that provides the pipeline for training, for validating, maybe for hyperparameter tuning. And you have a second sub-project that contains only this one class, or maybe this class and many other classes used for serving. So you have two worlds for every two views on every model: the view on training and the view on serving. And either you write a really custom code for every model as a Python class, like Mlflow, PyFunk, or like a Seldon Python component, or you keep reusable components as a multiple Docker images, and you need to keep this in some order. You need to version them, and what is the most challenging here is just you need to keep them in sync. So if you extend your training by adding more features as an input to a model, then basically you need to coordinate the change in serving part. It's like backend and frontend. So you need to either put some versioning or some rollout updates or something. You need to manage it. And all this is actually a lot of work to do, because it does not allow you to iterate quickly, especially when you want to do some changes in a model. And what if I told you that there is a way to keep both training and serving in one project? And you can test your serving, also known as inference. You may find this as a synonym for model serving, part without leaving Jupyter. So still, while developing something in Jupyter Lab, on Jupyter Hub, you can, on plain Jupyter, you can just test how the serving would behave without actually starting any microservice. And it doesn't create a new framework, this method. It just glues two existing frameworks together. It creates a bridge between them. Before I show this method to you, I need to introduce Kedro. Normally on non-virtual conference, I would ask who uses Kedro or who is aware of Kedro, but I do not see you folks. So I will just introduce, I will just do a simple, quick introduction to what Kedro is. So why Kedro was born and what challenges does it address? So first, there is no standard way on how the ML project should look like, but we as an experts in the area, or well, as the developers, we know some good practices that you should do a feature transformation, then you should split the data set into train part and test part, then you should fit your model on the train part, evaluate on test part, and maybe you should do some cross-validation, hyperparameter tuning, or basically there are some good practices. But there is no standard, and actually this is good that there is no gold standard, because then everybody would need to fit into the standard or would be forced to fit into the standard, and we know how broad ML area is. Reproducibility is the key. This is a super important thing in terms of this MLOps initiatives, that when data scientists is finished with implementing the code, the pipeline, it should be easily reproduced. It should be easy to reproduce in the environment that can retrain it on the full data set or on the environment that can serve it. So Kedro answers this reproducibility challenge really nicely by providing custom tailored environment for every model. Kedro fills the gap between data science and software development because it makes your ML project actually a Python project. So you have a versioning, you have unit tests, you have code linting, you have everything that software development already uses, but on your ML project. And how does it look? Before going to Kedro internals, I like to see Kedro as this button in this relay runs. Let's imagine this data scientist on the right that is just doing the latest fixes on the model, just doing just finalizing the latest functions, and the data scientist just wants this model to be deployed somewhere, and then the ML engineer takes this model, and if this model is Kedro based, these two experts they already speak same language, they already use the same syntax, and they can easily the model can be easily passed between these two without ML engineer to going deeply into the model structure, and without data scientists needed to understand all these challenges on the model continuous training, for example. So how does Kedro work? It provides three abstractions, I would say three building blocks. First building block is a node, then we have a pipeline, and then we have a data catalog. And I'm going to show you quickly what do they represent. So node is just a function. It's just a plain, pure Python function that takes some parameters and returns something. They are usually simple, testable, and well, you can write unit tests. You can just call them in any way you want. There is no dependency on Kedro or anything else in these functions. These are just Python functions. Then you have a pipeline. Pipeline is a collection of nodes and dependencies between them. And dependencies are marked as inputs and outputs. So you can see this input for this split data is master table, but here we do not define what master table is. Here we just say that, well, some master table will be passed as the first parameter to split data, and Kedro will handle it for us. Also, it will handle every execution model, and it would be DAG, like directed acyclic graph. And finally, we have a data catalog. So a place when the labels of your data sets, they become actually descriptions of what they are. Like companies is a CSV data set laying in some Google storage bucket in layer row, because this is used in very first feature transformations. It allows to split the data abstraction that can be reused. For example, data scientists can work on the samples of data on CSV loaded into their notebooks, But finally, when the model is passed to the continuous training, then ML engineer that provides new data catalog with original paths that contain full data sets, and this ML engineer does not even need to look into the code because it will just work if the schema is same. And it supports large variety of libraries and sources. So, main building blocks of Kedro project: node, function, pipeline, set of functions with their dependencies, and the data catalog, so abstraction on where do the data reside and how they should be loaded. If you can transform your ML project into something that uses these three abstractions, and I strongly believe you can, because this is, well, when you create some pipeline, when you create some ML code, this is just, you know, maybe this is a script that executes things from the top to the bottom, but this can be also represented as a set of functions executed in pipeline. So if you can rewrite your project into Kedro project, then basically you can reuse all the things that Kedro provides to you. That is integration with Docker, Airflow, Kubeflow, Mlflow, visualizations, and way more just by using these abstractions. And finally, the main topic is one of the integrations that, that we recently created between Kedro and Seldon for model serving. Usually in Kedro, well, especially in this quick start scenarios, when you try to start your Kedro adventure and when you download space flights quick start, for example, you have two pipelines in the beginning. First pipeline is named data preparation or data engineering, and it loads data sets, maybe it joins them, merges them, it does some normalization, maybe it drops outliers or something. Basically, it makes sure that the data are consumable by your model. So this is feature engineering part. And you have this other part, data science part, that splits the normalized data into train and test set. It trains the model, then it applies the model to the testing set. It evaluates it and stores the results of evaluation somewhere. So you have these two pipelines. This can be called separately or together, but this is like usual way how Kedro how you build a Kedro project. We created a third pipeline. We called it inference or serving pipeline. So first we have a custom node that loads an input. So it gets an input as it would be provided as a one row pandas data frame, and it passes it to some other functions. So this is just transforming of what user provided to one row data frame. Then usually we have some decoration. For example, if this input contains company ID and we need to get the rating of this company from some feature store, we need to decorate it, we need to call some feature store. So this has something in common with data preparation. Maybe it uses other database because, well, in data preparation you need data in batches. Here you need to do a key value lookup. So it has something in common with data preparation, but this is still a custom code. Then we just call this normalized data. And this is step borrowed from the data preparation. This is actually just a reference. This is pipeline calling node from some other pipeline. So we have reusal. Evaluate model is also part of the data science pipeline. So we basically call the evaluate model from the data science pipeline. And finally, we can format output. So we can make sure that the output is something that end user, the user calling our microservice, would expect, like kind of iris, and not exactly the set of probabilities. So how does it look in the code? I think we have enough time for me to go into Jupyter Lab. So Kedro Jupyter Lab. Just give me a sec. There will be some warnings because Kedro uses kind of old NumPy. But let me go to this pipeline and maybe I'll make it a bit bigger. This is our inference pipeline, and it contains 5 tasks. And first task is a custom task, select company, that gets what the user provided, all the data that user provided containing company ID, and it uses some kind of feature store to get the company row from this feature store. Then we have node borrowed from data engineering pipeline, here data engineering preprocess companies, that does exactly same preprocessing as data scientists did during the training process. So we make sure that exactly same set of transformations is applied on the data when these are served. Then you have prepare input. It gets some data from user input, it gets some data from feature store, and it creates a format that is acceptable by the model to finally do a prediction on the model. And this prediction, it goes to the user result, to something that is presented to the user as a microservice. And this is just a pipeline. This is just a third pipeline in this project. And if you want to try, if you are the data scientist and you want to try it, you don't need to run a microservice or build a Docker image or something. You just call it in Kedro run pipeline inference. And it executes this pipeline. It takes second or maybe more, maybe second and a half. And finally, we remove this file. It created this prediction. So what the pipeline did here, it took the input data from this data directory. It simulated what the model caller would pass, like company ID this, number of engines 5, and so on. And it started the pipeline, and finally it saved the result in some file that we can read. Normally this file will be provided to the user that calls our microservice. So this is how you can develop, how you can test the edge scenarios without going into some other projects, without actually leaving your Jupyter Lab instance, for example, the one that Kedro provided to you. And what about the serving? To show the serving, I need to. Okay, it's created. It's initializing right now. So when we do a model training, we pack the model into Docker containers, we ship it on Mlflow, on Kubeflow, so we already have a Docker container that contains all your Kedro code and all the dependencies. And we just start this container as a Seldon server. And this is exactly the Seldon server that has it. It uses this Python component, and this Python component initializes Kedro pipeline, and finally it just calls this pipeline. It simulates the input as a data frame in the data catalog, and it goes through the entire 5 steps pipeline to get the result and finally provide it to the user. Okay, 3 of 3. I believe this is running. Let me stream the logs. kubectl logs -f classifier. It should tell us, yeah, that the pipeline was loaded, that some pickled data set like model from Mlflow or some CSV as our sample feature store was loaded. And now let's try to call it. It should be deployed in this URL. Let me refresh it. Spaceflights Kedro. Try it out. And of course, I forgot to copy the sample input, Kedro input. We have some sample input to call this microservice. And it creates a data frame. You provide the names and you provide a list of values. And this gets transformed into this input of Kedro model. So let me do a log streaming again, and I will make sure that this is always on top. And I will just hit execute. And when I hit it, you can see that I got the response actually very quickly, that this moon trip will cost $2,700 in 2160. That's pretty cheap for the moon trip and going back to Earth. But you can see underneath what it did, what our code did. It actually started the Kedro pipeline, run the inference Kedro pipeline node. It loaded some data from the cache data set, memory data set, so we are not reloading the model of every run. Then it started executing of these 5 tasks that we defined in Kedro project before, and finally it provided the result to user so we can see it. And this is how we develop serving right now, and it has some ups and downs. Let me go to the next slide. I need to pin it. Okay, it has some ups and downs. So first, the advantage is that you do not longer need to keep 2 separate projects. You have one project that when you do a training pipeline, when you do hyperparameter optimization, and the same that you use for inference. So basically you keep everything in one world, I would say. It allows super fast iterating on the model, because if you add a new feature to the model, if you extend the model input, you just do the same in the inference, and then name of the image used to serve the model is stored near the model itself in Mlflow. So we are ensured that exactly same code that was used to train the model will be used for serve the model. And not only the code, but we also have identical Python versions and all libraries. And you may know that this is not a trivial issue when you try to unpickle model pickled on the other Python version. There are some downsides of this solution as well. It's not as fast as it could be. We measured that there is like 11 milliseconds of overhead in total. So maybe it does not suit every scenario. And in your training pipeline, you need to install compatible Seldon core package to make sure that these two tools can talk to each other. This brings some gRPC IO dependencies that may be not compatible with all the libraries that you use. But anyway, short summary. Kedro, Seldon, and Mlflow, these two, they make a very useful serving toolchain. And a few months ago, we didn't even think that this would be possible, but it turned out to be really useful scenario. Kedro proved again, because in Getindata we use Kedro on many projects, and it again proved to be all-in-one environment for ML on this experiment, because, well, you don't need to leave your Jupyter and you can do all your ML stuff inside Kedro. And the method is great for fast iterating. If you want to deploy the model in 10 minutes, for example, and you don't want to wait for some approval or something, but it may be not an option if every milliseconds count. So if you need your model to respond in 2 milliseconds, Kedro, because of this abstraction, because of using this data catalog, this is maybe not a good way to implement it, and you should anyway create a custom Python microservice. That's all. Thank you for listening. I hope you liked it. I hope you will try this. I was amazed how nicely it worked. And if you try it, if you have some feedback, let me know, because I'm really curious about your experimentations as well. Yeah, thank you again for listening, and maybe you left some questions on Teams or on the other platform that you use, Mr. Chairman.
We have some questions. Maybe we'll switch to Polish during the questions.
Yeah, that's fine.
Dobrze. Okej, ponieważ pytania mamy po polsku tak naprawdę. Pierwsze pytanie jest, czy Kedro jest mature enough, tak? Czy jest gotowe do tego, żeby używać go na produkcji?
To jest bardzo dobre pytanie. W Kedro dużo się zmienia. Między wersjami ostatnio wyszła 0.17, chyba 3. Między tymi wersjami pojawiają się małe zmiany. Oni starają się zachować kompatybilność i dość dobrze im to wychodzi. Tak, brak kompatybilności się przejawia w pluginach. Jeżeli ktoś pisze pluginy, to trzeba dostosować do na przykład 2 albo 3 wersji. Ale z perspektywy użytkownika Kedro jest mature enough. Używamy go na produkcji w wielu projektach w Getindata i jesteśmy zadowoleni, jakby nie stwarza problemów, również w ten sposób z serwowaniem.
Kolejne pytanie, czy performance tego rozwiązania zbudowanego Kedro jest porównywalne, czy jaki jest narzut spowodowany użyciem Kedro w porównaniu do samego Seldon Core?
Tak, jest narzut. Nie da się ukryć, że jest narzut, dlatego że Kedro przez swój system abstrakcji, przez to wyszukiwanie, który node powinien być uruchomiony następny, jakie są zależności, to jest jakiś narzut. To jest około 11 milisekund obecnie przy naszym 5-krokowym pipeline do inferencji. Tak mieszam polski z angielskim, bardzo przepraszam. Także jest około 11 milisekund. Dla większych pipeline'ów to może być problem. Ale na przykład jeżeli odwołujemy się do feature store'a, który i tak odpowiada w 50 milisekund, to 11 milisekund może być zaniedbywalne. Jest pewien problem performance'owy, ale nie jest on taki duży. Biorąc pod uwagę łatwość użycia, to w naszych przypadkach jest zaniedbywalny.
Okej. Czy mam jeszcze jakieś pytania? Nie widzę tu nic więcej na platformie. W takim razie, Mariusz, bardzo dziękuję za prezentację.
Dziękuję serdecznie.
Czekaj, jest jeszcze?
Aha.
jest jedno pytanie właśnie a propos tego narzutu. Ilość zapytań na sekundę per kontener. Czy to jest jakiś, czy masz jakieś to zmierzone?
To jest bardzo dobre też pytanie, dlatego że w Pythonie, jak dobrze wiecie, mamy GIL, Global Interpreter Log, i żeby to serwowanie szło rzeczywiście wydajnie, to trzeba tych kontenerów wyserwować kilka, dlatego że jakby one są blokowane. Przyznam się szczerze, że to też zależy od przypadku. Nie zmierzyliśmy dokładnie, ile zapytań na sekundę jesteśmy w stanie stworzyć, ale mając Seldona i mając autoskalowanie na klastrze, Seldon jakby fajnie to wszystko spina i możemy się bardzo dobrze skalować. Także nie potrafię powiedzieć teraz dla tego konkretnego przypadku, ile mieliśmy uderzeń na sekundę, ale nie jest to problemem, jeżeli mamy dobre skalowanie na klastrze, a Seldon nam to daje z automatu, niemalże.
Okej. Mariusz, dzięki wielkie za...
Dzięki wielkie i życzę wszystkim dalszej miłej konferencji.
Dokładnie. Teraz mamy przerwę lunchową.
O, no to smacznego.
Tak, dokładnie. Jest kilka prezentacji w trakcie i wracamy po 12, no przed 13.